She's like a migraine, I think.
Oh,
So like her eyes are hurting.
next year. What about Melinda? At least you guys aren't testing.
Yeah.
Oh, if I had to come back today and test, I would be heated.
Yeah, for 3 days in a row.
Yep.
I don't have money. Is Marcella on here?
She's not.
Where would you do that? Is that back here?
Alone.
I'm just taking precaution, people. We get dismissed at 2:15.
You
better go sit back there.
But they're gonna go by the, they're gonna go by the seating chart.
What kind of city, like, I'm not trying to say.
Yeah, I can tell them differently, but just tell them to remind me. Because otherwise they got our seating charts and that's what they go by. They don't even ask us. That's what I'll do right now, actually.
Yeah. It starts at like 4, but I don't know what time it is to be there, but.
Are they using this
When we should leave.
I have to run home and get
Oh, yes.
my like little hoodie thingy.
I'm sure if you just leave at 2:30.
Just like right over there.
I know, I like, yeah.
Are you driving?
Are you taking a picture for it? We're gone.
To show how distant you guys are.
Can we keep doing that? Can we keep like sitting like this so we can be?
Sure, you guys can do whatever you want. Yes, absolutely. If it makes you feel awesome, then yes, do it. All right. So Marcella, we are recording this for you. We're going to go over our fly data and then we're going to do gel electrophoresis and biotech and then talk about our lab for tomorrow. And I'm recording it for you. Miss you. Hope you feel better.
So nervous.
Yeah.
All right.
I mean, I lost my voice and that's been gone.
Yeah, that's kind of different.
And my throat's sore from that, but like I don't feel sick. So so
You got that?
Are you driving yourself?
Find that.
Yes.
Find this for Monday. And find this. This is from the.
But I'm sure if you get to.
Oh, sure.
Did they show it where he knows?
No.
They did that inside one.
Sarah, I will send you a picture of our data.
We're gonna share class data.
Are you getting a haircut?
Did he? I did, yes.
Oh,
Thank you.
Yeah,
You get one too, Nick?
I need one.
Oh,
I might keep it longer baseball.
Does she have all your data?
Yeah.
Cool.
So can I see the class data?
Yes. We'll just do class data. All right, so let's,
Did we get that one?
you got this before spring break and then, yes, that's it, because we did the data collection and then set our flies free on Monday, because they had been in there for a long time. It was gross. All right, so on this page S6, you should have written down your totals. And then what you can do is draw like a little line in your chart, like, so your top part is gonna be your data, and the bottom part, those are gonna be the class data. So for each one. So like draw a little line, and your data would be up here, right? And then class data are gonna be underneath. We're gonna share all those and add them up together. All right, so date's gonna be the same. You want F2 phenotype. You want females. Males. Those are share class data. Okay, so we're gonna do a little bit different than what this shows. We're gonna do a chi-square analysis next week with some M&Ms. That's a statistical analysis of data that'll be useful to you going forward into college. And then also Sometimes they ask a question about it on the test, sometimes they don't, just kind of depends. So we're gonna go ahead and do the chi-square analysis on these data, so we won't turn this lab in quite yet. We're gonna look at your data. All right, so we're gonna share class data, and for each phenotype, we had red eyes, and then we had normal wings, and then we had, then we did sepia normal, right? Is that the order that we had it in? I want you to get the same order that you wrote it. So you had red eyes, normal wings, sepia eyes, normal wings, and then you had red eyes, apterous wings, and then you had sepia eyes, apterous wings. All right. I selected this lab because I originally thought we wouldn't have time to do chi-square, but now that we're not doing a test, we have time for it, and I'm glad. So females, we're gonna add all these together. I'm gonna get my calculator out. Just write class data up there for you all. How many red-eyed normal wing females did your team have? One.
Really? Yeah. We had 14.
Plus
We had a lot
14.
of the males though.
All right. And then that was it, right? Because your data,
Yeah.
okay. We're going to actually, let's just add 18. 30,
This is what.
33. So this is your data up here. Then we're gonna draw a line, class data. Those are the data that we're gonna look at and do a chi-square analysis of. So 33 out of however many total, we'll count those up later. 33 females had red eyes and normal wings. How many males did you have with red eyes and normal wings?
8.
8.
We had 17.
Okay.
Sorry, we're putting our data.
Wait.
Up top, so here's your chart, right?
Melinda has the other half of mine, that's why I don't have. Melinda probably also has mine, because she's my partner.
Right,
I
we're
only
gonna
have- I
guess.
only have it back with like the.
I'm gonna throw some numbers in there for you, so it'll kind of,
Yeah, you guys are the only elite. team.
Yes.
We are.
your superstars. So underneath, you're doing class data. Now that we can do a chi-square, we're gonna do things a little bit differently. So just draw the line, and we're gonna do the same thing, but we're just recording the class data. The more data you have, statistically speaking, generally the more accurate the results are gonna be. So how many males you said you had? 8 and 17. I'm gonna add another 13. So we're gonna say 38 out of our total. All right, so now we're on to sepia eyes. That should be a lot fewer. This is what we're probably gonna end up with. Ratio. We had heterozygous in our F1, all right? Just saying. So our red normal, how about our sepia normal? How many females had sepia normal wings? 1?
Females?
Females,
6.
perfect. How many males?
6 as well.
Okay. 3, okay, so 9. Good. How many females were red eyes with apterous wings, the little nub wings? None? Okay. Any males? How about both sepia and apterous? Any females?
Oh, sorry, we said red actors first. We had 1 male,
We had 1 male, okay, got it.
and then none for the gold too.
And then 1, okay. Did you have any?
I had one for the females.
All right, sweet. We're gonna take a look at those data and we're gonna analyze them next week. We should have seen our projected would be a 9:3:1 ratio. Let's calculate the total number for these so we can see right now if we're even close to that. Because when we do a chi-square analysis, we're gonna say, statistically speaking, are our results different from what we expected? And if so, how much? Statistically speaking, if they're not very far, we're gonna put a number to that. If they're not far enough away from what we expected, then it's just human error. But if they're wackadoodle, the numbers are way too far away from what we expected, then that's scientifically something we want to pay attention to. That's why we do a chi-square analysis of the data. So something was going on, either it's because something happened, there was a mutation, then we need to investigate that, or whatever. So we'll do that analysis next week. So we had then, how many females? 33 plus 7 plus 1, a total of 41. Then males, we had 38, 9, 1, 40. So you can see right away that our numbers are off for this one by a lot, both males and females. That's pretty good right there. Those numbers are good and those numbers are good. So these look pretty good. So something happened with our actress ones, maybe. We'll take a look at that next week and find out, like, what's up? Did they just die off? Were those the ones that got stuck in the food? You know, we could be thinking about that. So we'll talk about that next week, but I just wanted to get your data together. Chemical waste disposal. What? I'm thinking, oh my gosh, what else is being thrown at us? No. Yikes. Okay. So Marcella, to include you in this, these are the data that we will talk about. No, but she said to record it for her. Everybody say hi to Marcella. Yay. And Melinda too. Hi, Melinda. Because we'll record it for both of them. Okay. I know. So awful. I hate that we test you guys so much. It's ridiculous. Okay. So now put yourself in a holding pattern. We'll talk about all of that next week. We're going to add a little bit to it. But for tomorrow and Friday, I had originally intended to do this anyway. We're going to do a gel electrophoresis lab, but we have to finish talking about what that is and how we use it. So remember last time, I think we left off, did we leave off talking about, did I show you some samples of gel electrophoresis like that were famous?
I
think
think
you did.
that, was this like the comparing DNA and stuff?
Yes.
Yeah.
Uh-huh. So we're gonna actually do a gel electrophoresis lab where you're gonna run your own gels and you're gonna see what you come up with. So I'm making your gels for that today, so it'll be nice and fresh. We will run them tomorrow. We'll learn how to load them. It's also a wonderful skill to have, especially because of the world that we're living in right now. When you got, probably all of you have been tested, right, for COVID?
Yep, got tested yesterday.
Okay.
Have not.
You have not, okay. Those of you who have, they use what most people accept as valid. The most valid are not the quick result ones, although we can use those. If somebody's having symptoms, there are enough viral particles, there's enough viral RNA, this is an RNA virus that we're dealing with. There's enough RNA to show up in a test. But to do a gel electrophoresis, you have to do what's called PCR. So on your results, you'll see PCR results at the top. And that means that they did what we're talking about right now. They made copies of the RNA that they found, and then they ran a gel on it to see, is it showing up that you have this viral RNA in your system, in the sample that they took, okay? And it's gonna show for the specific banding pattern. So we talked about how we can cut DNA and RNA with restriction enzymes. Are like little scissors that can cut it in certain places. And then this gel would be something that we would run with our DNA or RNA that we get. This is what we're going to look at tomorrow. How does it work? I'm going to go over this real quickly again, just because it's been forever and we were tired when we talked about it anyway. So this is a side view of the gel that you're going to look at tomorrow. What you're going to do is you're going to load your DNA into the well. And then because DNA is negative, phosphate groups that make up the backbone of DNA are negatively charged. So because DNA is negative, if we have a positive charge at the other end, what's going to happen to that DNA? What's it going to do? I'm back here, and I've got a negative charge at this end, but a positive charge at this end. So is the DNA going to sit there, or is it going to move? And if it moves, where's it going to go?
It's gonna move.
It's going to move toward the positive, right? It's going to be broken up in chunks. So the DNA I have in the refrigerator right now is broken up in chunks already using restriction enzymes. It's sent to us that way. So we're going to put that DNA liquid into the gel, into the wells, and it's going to separate out to create banding patterns. I talked to you about this before. What do you notice about the size of these chunks?
They're getting smaller.
They're getting smaller. Which size traveled the furthest? The biggest or the smallest? Smallest. So the smallest piece of DNA or the smallest piece of RNA, that's going to travel to the end. Now, can we see an individual piece of DNA? At all? Ever? No, everybody shake your head. Way too small. No. No. So we got to make copies of them. When we have lots of copies of them and then we dye them, then they're going to show up in big chunks. And that's when we see the banding patterns. So one piece of DNA, one piece of RNA isn't going to create the banding patterns we need. That's why we got to do PCR. We'll talk about that in a minute. I don't think we got to that part. And that's the part that's already been done for us also. Because PCR machine is way mondo expensive, like tens of thousands of dollars. So we're going to separate it out by size, positively charged pieces, all of it. Or sorry, positively charged is going to attract the negatively charged pieces. And it's going to end up looking something like this. It's going to be a little bit blue stained because of the dye that we use to make the DNA show up. And we're going to put a light underneath of it, and that makes it pop even more. So because each DNA strand, your DNA strand, has the same information as Katie's DNA and the same information as Nick's DNA, as far as like eye color is located here, hair color is located here. You're not twinsies or anything, but it has the same information. But because you have different lengths of pieces in between, restriction fragment length polymorphism is what that called. What's that called? RFLP. The pieces in between that information are different lengths. When you cut up DNA, your information for, here's what I'm talking about. So here's maybe the information for eye color. And it's the same information with slight changes because people have different colored eyes, but the gene is the same length. So my eye color gene here, let's say that Sarah's is here and Katie's is here. And then we've got something in between that doesn't code for anything, and there's a length right there. And then maybe the next one is hair color. Not as simple as that, but that's okay. But let's say that Katie's piece in between is only that long. So the pieces that separate out, this piece of Sarah's is going to be longer. It's not going to travel as far in the gel. This piece of Katie's is shorter. It's going to travel further in the gel. So it's going to create a different banding pattern based on, even though the information of the DNA is pretty much the same length, even though the bases are different, that's why we can have these banding patterns. All right, so boom, boom, boom. We're going to stain it. I will stain it after you guys leave, makes your hands nice and blue. Plus the process takes quite a bit of time to stain it and then destain it. But then we're going to light it up on Friday. We're going to look at the banding patterns, and I forget which lab I ordered. I don't know if it's a crime scene or if it's paternity.
Wait, are we doing our own DNA?
Unfortunately, no, because we don't have a PCR machine. We could normally, but we would need to make multiple copies of your DNA. That's where we need the PCR machine, and that's what costs tens of thousands of dollars. Otherwise, we could do our own DNA.
We could probably get it.
No big deal. Just write a grant. We'll just write a grant
Yeah.
for it. No problem. If
We
we
gotta make a viral TikTok to make money off of it.
yes,
And that's all.
if we could generate some income, we could really set up a sweet lab up here. I wonder if SVSU, maybe if SVSU has it someday, I'll check into that. Because we could do that in Cincinnati. UC, University of Cincinnati, had a PCR machine, so we could take our own DNA and go have it
That's sick.
multiplied. But I don't know if that's
We could go there. Oh, wait, COVID.
next year. Next year, everything's gonna be different. It's all gonna be good. Just is. It has to be, or we might be insane. All right, make sure that we got, this is a little bit off. Okay, sorry. I think that's better. Oh, there we go. All right. Which species are the closest related? 1 and 2, they seem to be closely related. What about the other ones? 3 and 4. 5's hanging off on his own. Yes? So 1 and 2 we could say are closely related. 3 and 4 are closely related. 5's hanging off there all by himself. We can create those cladograms based on this genetic information. That makes sense that a fruit fly isn't as similar to a turtle as a snake is, right? All right, so if we have the disease one tomorrow, I forget which one I've got, crime scene, disease, or paternity. We're looking for a particular gene, a mutated gene. So if you have a genetic diagnostic run on yourself, which you may or may not want to do, they're looking for certain genes. They're looking for certain banding patterns. Do you have the mutated BRCA1, BRCA2 breast cancer gene mutation? If you do, then there's some options that you can take a look at. So you're more likely to have breast cancer in your lifetime if you have those genes. So they're looking to see the Huntington's gene. If you have it, you're going to get Huntington's. It's like a no-brainer. If you have BRCA1, BRCA2 mutations, it doesn't mean you're going to get breast cancer. It means you have a higher chance. If you have Huntington's gene, you will have Huntington's and die from it, unless you get hit by a car or something before you reach middle age and it starts to affect you. So you might want to know that. You might not want to know that. If you have a genetic panel done, would you want to know if you have a fatal brain disorder? If there's nothing you can do about it? Would want to know? Raise your hand.
I don't know.
Nick, you'd want to know? Why?
No, I would.
You wouldn't want to know?
Yeah.
Okay, so why would you not want to know?
It'll just make you, it can ruin literally any good moment. You're just gonna be like, oh my god, I'm having so much fun, I'm gonna die.
Well, it's either that, you
Then
could
you-
live, but then you know, like that you can live your life, like
Yeah.
you're
Why
gonna.
wouldn't you do that anyway?
Yeah, exactly. I don't think I'd wanna know.
Right?
I think it'd be like always in the back of my head, like. I'm-
What about having kids? If you have that gene, that means 50% chance of passing it on to your kids. Would you want to know that?
Oh.
You'd adopt? But you wouldn't know if you're not going to find out if you got the gene or not. You wouldn't know if you should adopt or not. Right? These are tricky questions because it's not an easy answer. Do you want to know that information? Do
I
you?
wouldn't wanna know, and then when I'm wanting to have kids, I wanna know.
Okay, so you wouldn't want to know for yourself, but you wouldn't want to know for kids. Anybody else feel the same way?
Yeah.
Yeah.
Yeah? Okay, so you want to know because you wouldn't want to pass that on, right?
Couldn't you find out, like, once you wanna have kids? Like that?
You could find out whenever.
Yeah, you find out before you have kids and.
Yes, so Huntington's, this particular one,
That'd be so scary though, because you're like, yeah, I'm gonna die in my 50s.
Right.
When did they die?
about 5 to 10 years after diagnosis, unless you have a lot of CAG repeats. So part of the Huntington's gene is just a bunch of this cytosine, adenine, guanine repeated. The more repeats you have in that gene, the earlier it's going to strike you. Did I tell you about Sarah Kaleem, my student?
Yeah, you did.
So she has 111, I think, repeats.
Did she die?
She has not died yet, but she started to have symptoms. So her question was, and she's brilliant, do I go to college?
Yeah.
Because I mean, I
Yeah.
started to have symptoms. She could figure out a cure for this. That was my point to her.
Brilliant.
She's brilliant.
Good though.
But she could also just go on that and
Why
then.
waste like your precious time?
Finding a cure for the mankind,
We have.
that'd be amazing.
Yeah, school is the worst thing for everyone. Like, especially if she can use her talents to use.
Yeah, she's like
See the
good.
world.
at it.
If she's happy with it, then it's her life. She can choose how she's gonna do it.
Exactly.
If she doesn't, if she really doesn't know, then
Is it like a slow, like, painful thing? Or is it like a-
It is really awkward. So she has already started to have gross motor issues. So she trips. She stumbles a little bit.
That's really upsetting, like just knowing you're getting it.
Knowing that you're getting that. There are treatments that slow it down, slow the protein buildup down. That's what causes it. It's the Huntington's protein buildup on the brain that eats the brain away. But there's no cure yet. So
how was she diagnosed then? Like,
because her
What
dad
level?
had it. So then they had all the kids tested. She was the only one between her and her brother and her sister who has it. And she's the only one that has symptoms between, well, obviously. they
Those
don't have
kids who
it.
didn't pass it, they passed it down to their.
No, because they don't have the
I
gene.
don't think that's where they go.
So her brother and her sister don't have the gene. They're not gonna pass it on. But her dad's probably dead now because he was really bad when I last knew her, which was 3 years ago. He was in home care and he was a mess. And her mom was going to nursing school because she knew she was gonna have to support the family. So I think he was a doctor. I want to say her dad was a doctor. And then he got sick. And then mom's like, oh my gosh, what are we gonna do? And so mom went to nursing school. And then Sarah was deciding whether to go to college or not because her mom.
I mean, that's hard for the whole family though.
I wish
Heck
that's
yeah.
what
They
it
know
was.
that.
Because Huntington's people get mean.
Oh,
He
they
got
do.
really mean.
Oh,
Not only because you're losing all your faculties,
but you're mad.
but you're angry and your brain is messed up. It's jacked up. It's being eaten away. So your emotions are crazy.
Why did that make that happen?
Great,
Was.
great question. To draw us
made the
closer to
apple.
God is my answer.
You made the apple.
We just have a heart to heart, like, deep conversation.
No,
About
we're.
bad things.
Nick, did your experience draw you closer to God or take you further away from God?
Closer.
Amen.
But
That's why bad things happen.
I have people that I know that kind of were farther away.
True,
Yeah.
Weird.
but when they come back, it's gonna be amazing.
Yeah.
That's the goal, is to always go back to your source. That's what I think. But I'm just a silly high school teacher. All right. We did this, right? The crime scene, did we get this far?
I feel like my conversation started.
Yes, no? It looks probably the same. Who did it?
Who done it?
Who did it?
I
Crime
didn't
scene
watch that
sample. Victim is different.
It was good, it was creepy.
Us two did it.
Exactly.
Busted.
I think
We talked about this too, right? Okay, so we talked about why it's different. Yes, yes, yes. That's what I explained to you on the board. And then did we get to this part? Where we did this one?
Yeah, we definitely did
Talk
the
about this
rapist.
guy,
Oh, yeah.
Tommy Lee.
We talked about OJ too.
Oh, yes, okay, good.
Oh,
We
yeah,
got
cause
that.
we're like,
Love.
he can't like. make
This
up
one was it,
Yes, this is where we stopped,
Cause
right?
he like can't make up excuses for doing that.
the glove, the infamous glove.
And think about this, is I'm sitting there, I was in college when this happened, I think. Yes, I was pregnant and in college. And I was married by then, just in case you're wondering. I went to college for 11 years.
Wait, what you call it? 11 years?
Yeah, because I was an idiot party.
Wait, what are you talking about, 11 years?
I did. And I don't even have a PhD. I just had a regular BS degree.
You
That's
just
what I
didn't
grew up.
graduate, or like?
No, I was an idiot and failed my first 2 years, lost my scholarship, had to pay for one class at a time, and
Oh,
you know, I was an
That's
idiot.
a lot.
A lot of college, especially when you're pregnant and then you have a baby.
Oh my god.
But you figure it out and you do it. I remember crying a lot my last year because I'm like, this is stupid. I hate this. I'm so tired.
Wait, when did you graduate? When you're 30?
I was close. Yeah, I was 29, I think.
But hey, it's over now.
I'm not making fun of
Living the
you.
dream.
Okay.
Developing.
You know what? Exactly. I'm living the dream right now. So this was going on when I was pregnant, and I remember thinking at the time, the whole glove thing, like the glove no longer fit. Well, duh. If you have a leather glove,
That is the worst piece
That's
of
the
evidence
worst.
ever.
thank you, it shrinks.
That's what leather does.
That's what leather does. And I'm thinking that, and I'm thinking, why is no one bringing this up?
And
Why?
why is that like the one thing they use?
What's the glove?
So he had a glove on and they found a glove at the scene and basically, like, people are saying that he took stuff to swell his hand up because his hand didn't fit in the glove. And they were like.
They made him
said it's
try
like,
it on.
He's not guilty.
So they had this
Oh.
crusty, bloody glove that was covered with blood, right? Because that's what they used to murder the people. They used gloves and then stabbed them to death. So I remember him trying to put it on. Oh, he's just like trying to put it on. And I really didn't think he was guilty at the time. I wasn't really quite sure. But I thought that was a stupid piece of information. Like, of course leather is going to shrink and it's not going to fit his hand. It's got wet and then it dried. Duh. And nobody brought that up. Like, are you people idiots or
Was he
what?
not? Wait, who is this?
He was totally guilty.
He was guilty. Absolutely, because this evidence was thrown out.
You know, just-
They did genetic testing of all the blood at the crime scene. There was a lot of blood. Because Nicole Brown Simpson and Ronald Goldman
Oh.
were stabbed both times. There's blood everywhere. But they didn't just stand there like, oh, stab me again,
Is he
please.
in prison? now?
They fought back. No.
Yeah.
I think he got out, but he was only in prison because he broke into somebody's house to steal his own stuff. His own paraphernalia, like his
Wait, so,
ring or something.
oh, so this guy murdered people, but never really got prison.
OJ murdered, he wasn't probably the single murderer there. There were probably two people think. Because it's two, I mean, these two people were healthy and strong. They're not gonna just stand there, even though OJ was strong, there's no way one person's gonna be able to get both people
Yeah.
stabbed and walk away unscathed.
How is he not in prison?
Why is he not in prison? Because
Because
this
it's all-
got thrown out.
The glove. They didn't have sufficient evidence.
They didn't have enough evidence, and he had a really good lawyer. Johnny Cochran was a good lawyer.
So this dude just walked.
Because he
He's-
was rich.
And he
Oh,
went cuckoo for Cocoa
that's
Puffs. He probably had a CTE, one of those chronic traumatic encephalopathies with the multiple concussions, because he went crazy.
Who?
OJ,
Oh.
yes. So he probably is a victim of CTE, but he went bonkers and like broke into houses and got, He
Wait,
just
so
went.
wasn't
with
Nicole his wife and then the other guy was like her
her
affair?
boyfriend, yes.
Yeah.
But they would separate at the time because he was getting violent. He beat her up multiple times.
OJ?
Yes, before they got
Yeah,
divorced.
I heard that too.
And she said that he went through this dramatic change. Like he was a great guy, like a strong guy, but a great guy. And then he just went like crazy, but they didn't know about CTE back then.
Oh.
They just, you know, thought
And,
he was
and
crazy.
that's what we think it was because he played football?
Well, they won't know until he's dead because the only way you can find out is by sampling the tissue.
Oh.
It's crazy. All right. So OJ did it. Okay, this is where we stop, right?
Yeah.
So in the fraternity, is either parent going to have exactly the same DNA as the child? No, because that'd be weird, right? If your child is a clone of you, not gonna happen. So here's mom. You got two potential baby daddies. Which one you think is the baby daddy?
Two. Very similar.
Here's the kid.
Maybe I do.
Oh.
Yes. So that's when, you know, what's his face can come on, John, what's his face? Who's the guy who always does, you are not the father.
I haven't
More
actually
so.
seen an
Dr. Phil?
episode of
No.
that.
Jerry
You haven't?
Springer.
Jerry Springer, yes.
I wanted to watch it, but I don't know where to find it. I just wanna watch
No,
like one
he's the
episode.
one that they always fight, right?
yes.
Yeah, or they just, he creates drama.
Oh, yeah, it's huge.
Oh.
He's got these big bodyguards that come out and like get the people and they'll fight each
Can
other.
we watch an episode of that?
Why would you ever
Backwards,
go on
yes.
that show to actually determine if you're this kid's father? I don't-
Money?
Like,
Money and
yeah.
fame.
People just act crazy.
Crazy.
Yeah, it's.
All right, so the last little bit, PCR, how do we make all these copies of DNA? This is kind of tricky, but not too bad. So here's the one strand of DNA that we might have found at a crime scene, or maybe we found like 5 strands of DNA in a crime scene. We need to make millions of copies in order for it to show up enough in a gel for us. So we're gonna do what's called polymerase chain reaction, PCR, and we only need one strand of DNA to start with. We're gonna unzip it with our helicase, and then we're going to just put it in, we're gonna heat it up and cool it down, and we're gonna put it in with lots of bases. And we're just gonna get copies and copies and copies of the copies and copies of the copies exponentially. That's how PCR works. So what do we need in order to do this? We need several different things, and they figured this out, oh, probably about 25, 30 years ago now. I don't know, 30 years ago. So the primers are going to tell us where to start making copies, because maybe we only want copies of certain parts of the gene, parts of DNA, certain genes, right? And so primers are going to break up that DNA once it's been unwound, once we've unwound it, and they're going to choose different parts of the DNA to bind to, and they're going to be like the starting point. Remember how we had, when we made copies of DNA, we would unwind it, and then the bases would come in and start? We have to give them like a reason to start copying. So that primers are like the reason to start copying the DNA. We have to trick it into doing that. So we have to break the DNA down, and we're going to heat it up to do that. That's called denaturing it. That's going to be our unzipping tool. And then we're going to cool it down, and we're going to have it go back together again like it should. So you got to heat it up and then cool it down without breaking it down. And we got to do that with enzymes. And what happens when we heat enzymes up to like 90 degrees Celsius almost boiling?
They break down.
They break down. So you got to use special enzymes in order to do all this stuff. And we're going to use what's called Taq polymerase. And we discovered it in these hot geyser springs. Bacteria lived in there, and they're living at like almost boiling temperatures all the time, and they're functioning completely fine. So we took their enzymes, made copies of them, and then we used that enzyme to do what we need to do. This guy figured it out, Kerry Mullis. He's kind of arrogant a little bit. I've seen interviews with him, and he thinks he's the bomb.com for doing this. He got a Nobel Prize for it in '93, so I guess I think that was pretty cool too. But if you read his writings, I read a couple of articles that he wrote, and it's just like so obvious that he thinks he should be like a deity or something.
Oh.
All right, so that's what we're gonna do tomorrow. I'm gonna show you one quick thing. Walking through the lab itself, because all this stuff is gonna be new, and we'll spend most of our time just kind of going over what these things are. She doesn't feel well, she said. Hopefully she'll be back. She has, I forget what she said.
She stayed home.
I said on
Feel
Monday,
good.
I'm good.
Are we hating on Nick because he doesn't feel good and
Oh,
he's
yeah.
here?
As he was talking, he was like yakking in the home.
What?
I had once.
Wait, Nick, you got tested, right?
Maybe.
No,
you didn't.
I get this shit after that.
Yeah, you're fine. We're all fine.
Not a sketch.
For all I know, I
You
could be
need your meds,
completely
but they
fine and
said
still
they
have
call
it, like, you don't know.
I know,
Never got
lots of people. You could probably have the antibodies for it and never know that you were exposed.
Yeah, well, no,
Yeah,
I had it, that.
Oh, you did,
It like, kind of the middle of January when I was like out for 2 weeks.
right?
So-
Okay.
And I had it then, so I don't know if it's still possible for me, if it's been over 90 days.
I know, but our immune systems are pretty darn good.
We will not be
You
done by
got 6
You
weeks.
guys all going home.
Well,
You have it in 90 days or something?
I had it in the middle of
You have
January,
your goggles on.
She said she had it. Did you get tested and it was positive?
yes.
Okay, so you had it. You had it.
But I'm saying like, I'm fine now and I still,
You don't have to get tested.
has it been 90 days though?
Yeah,
If
Or
it's
is
been
it-
90 days, you have to get tested
If
because
it's
they're
been
assuming
90
you're no longer.
Middle of
Yeah.
January though, that's pretty much 90 days.
that's like right
Yeah,
now.
that's
had
why I
it
have
first
to
week
get
of
a test
February.
tomorrow because I could be fine and still have it, like, you know.
Yeah, I feel like.
That's what I'm worried about, like, I feel fine, but like, watch me have
Wait,
it,
what-
you know, I'd be
let
so
me-
mad.
Let me look at the calendar.
I couldn't tell you when it was, well, I could if I did some digging, but it's.
So you had it middle.
And that's not an exact science. The 90-day
Yeah,
thing.
I'd
yeah,
say,
that's the
I'd
thing,
say I
yeah.
found out like the 10th or 11th, around
So
there is
it's the
when I
14th,
found out.
So it would have already been. 5 days.
But that's,
Oh,
it's not a
I-
magic number.
Yeah,
It really isn't. You could be immune the rest of your life after having had it.
true.
You just don't know.
Yeah, exactly.
Everybody though is supposed to get the vaccine. So that must mean that we're not gonna be immune even if we had it, like twice like father had it. It's crazy.
You gotta make sure that you have your gloves on and that you have an apron.
All right, yeah, we got you.
And it should be tied in the back.
All right, so this is what you're gonna look at.
What you're gonna do next.
Are we gonna
is
do this
on the
on the
left.
Yes.
You have a few pieces of equipment out in front of you. The first thing that you're gonna need to
We're
record
gonna
is your
need
gel,
this
which is
or
right
this.
here.
I'm making
Your
that
teachers
check.
have already made this for you and it's set. These little indents right here that we're looking at, those are your wells. Now this needs to go into your chamber, which is this structure over here. This is the bottom part and this is the top that goes with it. To prepare it to go in, I need to remove the bumpers. These are
Positive
these
charge,
red positive
negative
parts inside.
charge.
These were used to allow the gel to set, but now that we're actually gonna run it, we need to take them off. So they are just squeezed on the edges, so very gently but firmly, I pull them
This
directly
will
off
already be off by the time you get
in each direction. All right, so now that I have my bumpers up, I'm gonna pick up my plastic container for my gel, and I'm gonna lower it slowly into the chamber using the channels to kind of keep the plastic mold in place. Oh, the way that
She made a mistake. So here are the wells, right? No, the wells are down here. And here's the negative end. No, here are the wells. Here are the wells, and here's the negative end, and here's the positive end. If the DNA is going to be attracted to the positive end, and the DNA is already down here in these wells, it's gonna go this way. Right? So that's why it's important. This is the super, like, most important thing for tomorrow, is you gotta make sure that your wells are down here by the negative end, so that they're gonna be, the DNA is gonna be drawn toward the positive end, and she picks up on the mistake that she made.
I wanna do it is you wanna
There you
pay attention here because you'll have two different colored leads coming off of here. You'll have a red and you'll have a black. Now DNA is negative, meaning that it's gonna run towards the positive. So I just put it in the wrong way with my DNA chambers facing towards the red, towards the black. And I wanna orient it this way. So the reason that I want it this way is because I'm gonna load my DNA sample in here. The current is gonna run negative to positive, so that means that my DNA will run towards this positive end here. So you wanna have your chambers that we're gonna fill closest to this black end, and you wanna have the direction that your DNA is heading towards the red or your positive end. Now that I've got it set up like this, I'm gonna add my buffer in. On the front of your chamber, what you'll notice is that there is a line right here that's labeled fill line. This is the maximum amount of buffer that you're going to want to pour into your chamber. Now, what you're looking for as far as minimum amounts is you want to make sure that you add enough buffer to this gel that you are going to cover the gel.
What's the buffer do?
The buffer is gonna conduct electricity, and it's gonna
So what
keep
we've
it
done there is
also
add
from,
enough buffer so that we're
keep the gel from burning up because
So
of
you
the
guys
electricity
say
going
you
through.
have to go up to this fill line, we just want to make sure we don't go above that fill line. Now, you may notice that when you work in there, that your gel floats a little bit because we just added buffer to it, that is fine. If it detaches just a little bit, it's not a huge concern, you can still load it, you can still run it. All right, the next thing that I'm going to do is I need to actually load my samples into each of the chambers. Now, in order to make sure that I know where each of my samples have been loaded, what I've created is a little bit of a lane map. Now, you are going to add yours, you want to make sure you're labeling your lane map because you'll be sharing with another group. We'll notice that we have 8 spots on our lane map. The 2 on our edges right here, so the furthermost out chambers, you are not going to use. So those are going to stay empty. And the reason for that is that when the gel sets, it's possible to get tears in those ones, so that if you load it with sample, it'll just seep out into your buffer. Now, what I need to do next is I'm going to start over closest to me, and I'm going to start in my second chamber and load my first sample in. As soon as I do that, I'm going to have my partner record what I'm recording, what I'm entering in there. So I pick it up, I see what I'm looking at. So this is my Pennsylvania strand. So my lab partner is going to fill in.
Yours will look similar, but it's not the same labs. You're gonna have those little tiny tubes and you're gonna use this micro pipette also.
Now, there's just a little bit of liquid in here, so to make sure I'm getting the most of it, I'm gonna tap it down like that, just to get anything that I have off the edges. Now I'm gonna pick up my micro pipette. You'll notice that there's a little bit of a tip right here. I'm gonna use my pointer finger to kind of support that tip. My thumb is going to go on here to press down and make sure that I'm getting my sample up and to deposit inside my gel. To
And
get
we're
the
gonna
tip
practice
to actually
before you
pick my sample up, you're gonna have one of these containers by you. You're going to put this in here and place down firmly to make sure that you get your tip on. Once I've done that, I open up my sample. I'm then going to put this straight down into the sample. I'm gonna push down, and what you'll notice is that there are 2 stops. There's one where you're gonna have a soft stop right there. And that's gonna basically give you a little bit of resistance. And if I keep pushing past that, I'll get to my second stop. To load my sample, what I do is I push down to the first soft stop, and I insert it into my sample. I wanna make sure that it's submerged in there. And then I release and allow it to draw back up into my tip.
It's
What
just
you should
a
do is do
tiny
a
little
visual
bit.
check now. You should have your
Tiny,
sample
tiny.
inside your tip. So there we are good. We've got our sample loaded. Now to put my sample inside, I know that I've already labeled that I'm going into my second chamber. So I'm going to position myself so that I'm looking over and directly down. I'm going to use my hand, my non-dominant hand, to support my arm to make sure that I'm being steady here. What I need to do is go in directly down at a 90-degree angle into my chamber. I want to be careful here not to puncture the bottom. Now I'm going to push down. First to my
Put the
soft spot,
DNA
then
in
all the way
there
down.
Without
and then I will draw
puncturing
out.
through the gel. You don't wanna do that.
What you were looking for right there is you should do a visual check on your chamber to make sure that you have filled it up. If you puncture through the bottom, what you'll see is your stain starting to seep through the bottom. If you've missed your chamber, you'll see your sample start to float around in the buffer above. So that's how you're gonna load your first chamber.
You put it into,
At each loading station, there will be a beaker labeled waste. Once I'm done loading. each
Here's
of
your
my
well
samples
from the
will
side
actually
view.
not pass contaminants.
put it down in here and then don't touch the bottom, because you don't wanna puncture through, then you're gonna let your DNA go. So it's in the well, but it's not punctured in the gel. Does that make sense?
My second sample. So I'm looking at my second one. This one is called Missouri strain. So I asked my partner to label my third lane in this case with Missouri. I tap down to make sure that I've got it in there. Remove the cap. I then come over here and push down firmly, make sure that I have my second new clean tip on. I'm then gonna push down to my first step. I'm gonna insert it into my sample. Keep my eyes on this, make sure I've got this what I need. Pull it up into my tip. Back down. Now I come back over. I wanna make sure, it's a little difficult to see, so I wanna make sure that I'm using the correct lane. I use my non-dominant to support my hand, and I go down directly into the chamber. Push down first to my first stop, then down to my second stop, and then pull directly out straight. All right, now that I'm done with that one, I take the tip off and I'm just gonna repeat this one more time. So pull the tip off of this one, put that away, turn the cap onto this one. Tap down my third sample. I read what it is, so this is the Alabama strain. So I asked my partner to label our last lanes. In this case, this will be the fourth one in Alabama. I remove the top on this, put a new tip on, place firmly down, push to my first soft stop, insert it into the sample. Draw up. Put this back down. Come back over to my gel. Support my dominant with my non-dominant, come in straight down, keeping my eye on that chamber as I go. All the way down to my soft stop. And collect. you get a little bit of dye outside, that is absolutely fine. You remove your last tip into the waste container. Now, at this point, I've used all of my materials. So I'm going to make sure that I clean up after myself. And then I'm going to let the next group go. They're going to use their 3 empty lanes to load their materials in. All right, so now that we've got our lanes all loaded with our samples, each group is gone. What we're going to do is plug this into the power box and actually run this gel. So remember, DNA is negative, so it's going to run towards the positive end, and that's how we're going to see our banding. So what we'll notice here is that we should have black wires coming out. On your power box, you'll notice that you have a sign that is black colored. So it's got a nice plastic label on the inside that corresponds with this, and it has the negative symbol. So I'm going to plug that in there, and then take my red lead, which is my positive. And again, I see my red color in here with my positive symbol, and I plug it in there. I want to double check to make sure that this is pushed up to 110. And here is your reading. So if you want to check it afterwards. The last thing that I'm going to do is make sure that my wires are running through here, and I need to put the top on. So I'll push down firmly, make sure that my leads are connected here. Once I have my leads connected, my top on, the last thing I'm going to do is turn it on. You should notice that the red light comes on to indicate that there is actually electricity running into this apparatus. The last thing that we're going to do to make sure that this is actually working is if we take a look very closely to the negative end, you should see bubbles coming out, and they should be flowing towards your red or positive end. This is what we actually are seeing here in terms of the voltage or the charge traveling across our DNA. This is what's physically going to pull those molecules towards the positive end. So we see those banding patterns. All right. So now that you're done running your gel, you're going to remove the top off of here. You should check to see where your bands are. So they should be about maybe a ½ inch or so from the end of your gel. You do not want to allow it to run off. So then you're going to reach in. You're going to pull out your container. Your gel might be floating around.
If you keep that plugged in and stick your hand in, what's gonna happen to you?
Shock.
You'll be shocked. It's not gonna kill you, but it's a shock. We're gonna make, hey, try that.
So once I pull it off, what I'm going to do is put my gel into my staining tray right there. So it slide very easily off.
Exactly. It's a little touch.
What I do now is put my final stain, so my Carolina Blue DNA stain on here. Now this will stain your skin as well as your clothes and everything else. You want to make sure that you're wearing gloves, goggles, and that you're being careful. When you pour this in, you need just enough in order to cover your gel.
So now it should have separated out, but we're gonna stain it. And then we're gonna stop right there because that's the part that I'm gonna do.
this is in
Once
here,
we
set
might
the-
get to fully run your gels tomorrow, or I might have to unplug it. I used it for the freshmen and our machine runs pretty quickly here, so.
You did this for the freshmen?
But just a basic one. We didn't do like what you guys are gonna do and analyze it and all that kind of stuff. I just showed them how it worked. All right, let's see and pray because there are no today. Yes, we do. See you, Marcella. We'll zoom you in for the lab tomorrow.
Bye, baby.